Hello, this is Scott. Welcome back to my YouTube channel where I cover a variety of different data science and analytics topics, everything from open discussions to platforms. Today we're talking about a platform, a commercial platform called Statistica, and we're expanding upon our non-supervised machine learning series. We did agglomerative clustering last time. Now we're going to get into k-means clustering. And what that looks like within Statistica. So I'm going to go up here, I'm going to open an examples, go to data sets, and then I'm going to select my marketing data. All right, so I have a data set here. This is marketing data, primarily a bunch of categorical variables that bend into categories for annual income, sex, marital status, age, education, occupation, etc. And what I'd like to do is see how I'd like to generate some clusters, how these things associate, and can I define individuals? Can I assign individuals? Each row is an individual into a grouping. All right, so I want to be able to assign the individuals into a grouping. So let me illustrate with a workspace because it's always easier to visualize. So let me just go new workspace, and I'm not going to select a template, and I'll select the data that I already have up. So I'll click, and then Statistica drops this marketing data down into a workspace. I'm going to use a feature finder, and I'm going to point out something for you. If you go to cluster, note there is an SVB node here, and if I select that node, the node itself will have a little SVB at the top. In fact, I can do that just for you. And then let me do that again, and let me show you which one I'm illustrating today. I am illustrating this one. So I'm not using the SVB node. I'm using the more recent developed node for k-means clustering. All right, so variables, I'll select everything, all my data except for sample. That's basically a split, a partition. I won't use that. And I'll get that that warning, and I'll just select continue. And my variables, I'm going to use cases. I'm going to cluster by cases, not by columns. All right, so rows, not by columns. And then the advanced, I'm going to use the default. The results, I can select analysis of variance or group of means. Analysis of variance doesn't really apply here for this particular example. I don't have any continuous variables that I'm trying to use an ANOVA for. And then I could select descriptive statistics, but what the heck. I'll go ahead and select both those options. And then downstream, I want to assign membership for each row, what cluster that they're going to go into. And I'll click OK, and then I'll run this cluster. Run this. Okay. So let's look at the output. Let me expand this so that we can see a little bit better what we have here. So we just generated this output, and then we can drill down into it. All right, so this first is the cluster means, right? So for each variable, there is an average assigned to the cluster. So I can see that, for annual income, it's 4.4 for this cluster. It's 4.9 for that cluster. So pretty close together for that variable. Looky here, though. Length of stay, or whatever that variable is, there's quite a bit of difference between these two. So there's a huge separation for that variable between these two clusters. Excuse me. The point being that there is separation, number of household members, there's a pretty good separation there as well. So the point being is that the cluster separates on certain variables and distinguishes between them. So those are going to be good predictors of which cluster that is assigned. I can also look at Euclidean distance. and this is a distance between the two cluster centers. And then I can look at again, the mean. This time I get the mean, but I also get the standard deviation, overall, descriptive statistics, etc. We're going to look at this in just a minute. We're actually going to use this, but this is the distance of each case, each row, each person or household from the cluster, the center of the cluster. So low numbers means that it assigns pretty strong to the cluster, and then high numbers mean that it didn't assign very well, so it doesn't really associate with the cluster. And let me do something real quick to kind of illustrate that. I'm going to go up here to data, and then I'm going to merge, and then I'm going to concatenate variables, and I'm going to take the output that I just generated, this output right here, which is the distance to the cluster, and the concatenate. So let me run this, and what I should get is I've got my variables here. Let me expand this. So I have for each row, right? For each row, again, is a household, right? And what the occupation and everything is. And then I can get the assignment. Missed something. Hang on just a second. I'm not sure exactly what happened there, but I'm still using the concatenate variables node. I just reconfigured another one, and with the same hook, basically the same hookup and everything, and then reran it, and I get the distance. So the distance is coming from my cluster clustering technique, and then then I have my other variables here as well. So a really interesting use case is to determine anomalies, right? So these low value distances means that these variables or these households are assigning to a cluster, whereas the larger ones, they're further from the centroid, the center of the cluster that they're assigned to, which means they're kind of an anomaly. And what we can do is we can look at those individuals. So you can imagine, and I'll do this if I haven't already done it. I'll do an anomaly detection example where I now take this output and I try to determine now a supervised model where I'm going to try to predict the distance with these other variables. So I can turn this around and create now a supervised learning method where I'm trying to figure out what is driving these anomalies from the underlying data. Of course, I could do correlations. I could do like a heat map or something like that. I can do visualizations, but I can also do a machine learning method as well. So I can either do it with visual discovery, what's driving these higher, these numbers that are further from the cluster, or I can use a machine learning method. All right, so next time we'll be talking about the expectation maximization way of clustering, or the EM algorithm. Hope you can join me.